Hi, welcome to Chem 6161. We will do the Diels Alder exercise. Okay, here is the first exercise. We are using this diene and this dienophile, and they ask to check the final configuration of the Diels Alder product. First, we go for the ratioselectivity. Remember how we can do it? Basically by orthopara, but in this case, the rule of the orthopara will be confusing because always we will have one substituent or the methyl or the ketone in the para position. That means that I will do it because these two compounds are very differently electronically. I will check which is the density positive charge, the density charge in each carbon, and then I will do the ratioselectivity. If we have a methoxide here, this is lambda plus, lambda minus, lambda minus, lambda plus. Okay, on the other side, if I have electron with grabbing group here, I will have lambda minus here, lambda plus here. Okay? That means that the reaction will take place with this ratioselectivity. Then I draw in a plane perpendicular to the slide the diene, and I approach the dienophile, in this case from the bottom, but I can put in the top, okay, because it's not chiral the reaction. And remember that has to be an endo approach. That means that the ketone has to face the dienophile, and then because this is a trans alphabet unsaturated ketone, the methyl is going outside of, in the opposite direction that the dienophile. If I do the reaction, what I get, okay, I am forming this bond from the top. That means that the ketone will be inside, and if I am forming this bond from the top, the methyl will be in front of us. Okay? Remember that this is a mixture of the stereomers. That means if you get this, because your approach has been from the top, you will get this compound. Okay? You will get the enantiomer. Okay? Good. Go for the second one. The second one, basically we are reacting exactly the same as before, but this time with a substituent here. That will be a methoxide. And we are reacting with this compound. Okay, we do the same than before. Okay, I assign the density charge of each carbon, negative, positive, negative, positive, negative, positive. That means that this will be the approach. I draw the double one, the diene perpendicular to the slide, and I draw the dienophile perpendicular. I will attack from behind. Okay, endo approach. That means that the R has to come inside of the dienophile, and basically this is the reaction that I am doing. If I translate this, what I get is this compound. Okay, if we are forming this bond from behind, here means that the methoxide will be inside the slide. If I am doing this carbon from the top, means that the carbonyl group will be inside. Okay? Remember that if you do the approach instead from the bottom, from the top, you will get the enantiomer as I showed you before. Okay? Next one. I have now this di, and I am reacting with this dienophile. Okay, I am doing exactly as I done before. Ratio selectivity. This is the correct way to do the reaction. I draw this perpendicular to the slide, and then the approach, end approach, that means with the carbonyl inside. Okay, and what I get, I put that the approach is from the bottom, it's not chiral, that means that I can do bottom or top without any difference. I will only get a different enantiomer growing, and then I draw the final product. Okay, if I am forming this bond from behind, the methyl is going inside. If I am going this from the top, this and the phenyl will be, if I am forming the bond from the top, the phenyl will be also in front of the side. Okay? Right? Okay, next one. The next one is this compound, okay, that is reacting with this. Okay, again, if we do the ratio selectivity, we will find that this is lambda negative, lambda positive, lambda negative, lambda positive, thanks to this methoxide. Okay, and then we have the approach of this compound. That this is more electronegative than not the ester, this will conclude that this is lambda negative and this is lambda positive. And we will have this approach. If we do it, what I will draw is here, I will put R. I don't care if it's cyclic or not. Okay? And then after this I will draw the final structure. Again, I put the diene approach from the bottom. Here will be the... In this case, the endonex approach is not so clear. That means whatever approach you are using should be okay. I use this approach because I consider that the aldehyde will provoke that this is the end approach, but as I told you, it's not so clear. Like this is clear the ratio selectivity because this an aldehyde is more electronegative than not an ester. In this is not clear. That means if I put this in exam, both answers will be correct. Okay, I do this. this is the approach. If I am forming this bond from the top, CHO down and methyl up, and the ester will be up, and this, if I am forming this bond from the bottom, what I will have is the R grow down. And then the only that I need is to grow the final product, basically. I only have to add the R. This will be the final product. Okay? If you do the approach that consider that the endo approach is just the opposite, also will be okay. Okay, next one. What we have now is this compound. Okay? The first that I will recommend in this type of exercise is to numerate. It's easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will help a lot this will help you in order to draw a structure. And then the Diels Alder will take place between this diene and this alkene. What I will draw is first this alkene, and then okay, I start from here. I remember that I have to put the diene in a schizoid conformation. Okay. And then I begin to put the carbons. Basically this is crowns here. This is number 5. 6. 7. 8. 9 and 10. Okay? Then what I have to check is that what I will form is basically these two bonds. And I have to be aware that this is a 6-member ring. That means I can draw the transition state in a chair approach. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I can do this approach. basically the only that I need to do is to put the substituents. Okay? The 6 is going down. That means that methoxide has to, the methyl is coming here. In the 7, this is going up. I am doing it right or I am doing it wrong? Let me check. 6, 5, 7, 7, 8. Yes, right? The 8 is going down, that means it will be here. This is, sorry, this is OR. Okay? That means in this chair what I have is all the substituents in the equatorial position. If I will do the order chair, that means this chair, okay, what I will get is all the substituents in the axial position. I have to draw a chair that is more stable. Okay, in this case will be this type of chair. And then the only that I need to do is to draw the final product. Basically, this is 2 rings. Okay? And the only that I need to do is to numerate. This is the carbon 4. This is carbon 9, carbon 10, carbon 1, carbon 2, carbon 3. Okay? And then here will be 5, 6, 7, and 8. Okay? And now put in the substituents. I will put the fixed substituent. For example, carbon 6 is going down. That means this will be methyl. OR is going up. Okay. This is going down. Okay. Then carbon 9. I do this approach. If I am forming this one, this is behind. Okay, and this is in front. If I am doing this approach, this hydrogen, okay, is going up. Okay. 3, 2, 1. If I am doing this one, this metal is going down. Yeah. If I am doing this one, this is in front, that means the hydrogen will go down. It's difficult to see, but please use molecular models and you will see that this is the final configuration. Okay? This is a very difficult example, but this is the final configuration. Okay? Right? Okay, the last one is by far more difficult and we'll have a video alone. The last exercise, okay? And that's all. Thank you for your attention and see you soon.